Welcome to the second webinar of the FAIRWork project. My name is Wilfried Utz and I will be the moderator of this webinar. The webinar is titled Developing Digital Process Landscapes, specifically within the Flex and CRF scenarios. So what we want to give you in the next 30 minutes is an insight of what we have accomplished so far in the FAIRWork project. The project started in September, and the first phase was related to understanding the use cases at our two pilot partners that are part of the project. What we will have prepared for you will be a good overview of the project, but then specifically focusing on those aspects. In the bottom right corner, you will always see who is presenting and who is actually talking to you, so that we have an idea who is your guide on the specific slide. But without further pause, we will move on, and I would like to hand over to our coordinator, Robert Walsh, to give us an introduction on the project and on the work that we have.
So thank you, Wilfried. It's an honor to introduce the consortium. We have two end users, CRF and Flex. As you can see, the logos. CRF, car manufacturer, Stellantis Group, and Flex, a worldwide acting producer in Austria in dealing with electronic parts, with robots. We have a research community, Union Research, dealing with data, Molecular dealing with multi-agent, and EWDH Aachen dealing with knowledge management, human and technology interfaces, and the companies BOC in terms of modeling, and Jotne with data marketplaces and production data. Omilab is a non-profit organization, as you already saw by Wilfried, dealing with this exploitation and the laboratories on robotics and modeling. On the next slide, you will see the project idea. The project idea is basically that currently persons make decisions. You see here the cloud, so workforce safety, time, machinery lifespan, energy consumption, etc. And typically this is done by one person in a centralized manner. And we would like to decentralize and in the same way democratize these decisions. So at the bottom you see different actors, personal needs from workers, vehicle conditions, machinery conditions, robot capabilities, etc. And those we call agents. And these agents will introduce all the relevant data into what we call a knowledge base. And to bring this person on the top, which has to make decisions with the data that are in the knowledge base together, we have the concept of this orchestrator. The orchestrator is bringing human, AI, data, robotics together in what we say manageable way. What we mean with manageable way is on the left side, we have a configuration environment to manage all these complexities. So the more complex the system is, the better you have to manage and control it. There are experimentation laboratories, there are guidelines, there are also other aspects like organizational aspects. So to have a transparent way of how this all is orchestrated. But we also have on the right side and so-called AI enrichment, where we have not only expert knowledge, so the retrieval out of the what we call asking the people and heads of the people, but also data from external data and of course artificial intelligence algorithms that introduce this into the orchestration. So that's an overview on what this means. I think Wilfried we will hear in the next slides.
Perfect. Thank you, Robert. We need to think about how can we make that happen. And I would like to start off with, let's have a look into research and how this research concept is established. And I would hand over to Sylvia to give us an introduction on that one. Thank you.
Thank you, Wilfried. I would like to introduce an abstraction of the decision-making process. Such a process consists usually of three elements like design, decision, and execution. So let's imagine we are in production environment where the tasks sequence can not only be linear, but also more complex, where the design have numerous possible solutions. So really like a live example. Following, the decision is made by the decision maker that could be a human, but also a software. Such a software can use advanced technologies like artificial technology, artificial intelligence, to also support a human decision maker. Of course, to make it possible, the digitalization needs to take place. The execution of the decision can be done using different sets of the instances. At the end of the whole process, of course, we should reflect on the results, learn, and improve our design to improve our decision-making process. Thank you.
Perfect. Thank you, Silvia. I would hand over now to Professor Böschen to give some insights on how the context of the human actually is important for this decision-making with respect to transparency and trust. Professor, the floor is yours.
Thank you very much for this opportunity. Here it's because important to think about two things. Typically, we are focused on humans and the interaction between humans and technology. That's clear that it's an important aspect. And therefore, we look at this interaction situation between humans on the one hand side and AI and technologies on the other hand side. And the question is, what about the relation? How is the relation designed? How is the relation practiced? And therefore, there are two important things which create an impression about this interaction situation. It's about, first, understandability. Humans have to understand what about the technology is. And if not, there is a problem. If so, it's fine. And therefore, it's important to know insofar humans understand what's going on there if they use an AI technology. On the other hand side, there's the question of trust. It is linked with the question of understandability, but it's a question in itself. And therefore, we have to look as well on the questions of acceptance, trust, and the use of specific technologies. It's in the debate about AI and the ethics of AI, the question of explainability, trustworthiness are highly important. And they typically relate to this complex relation between humans and AI. But we have to be careful about that, so that we not only look at this part of the interaction, as interactions are typically embedded in more complex interaction situations. So there are environments, there are contexts which are socio-materialized, and therefore we also have to have a look on these environments and to better understand how these human technology interactions are placed. And these are the questions which are aligned thereby. So the first question is, what does successful AI-enriched decision-making look like for the human stakeholders? Here's the focus on the human stakeholders. With the next questions, we shift a bit the focus towards the environment. So how are individual practices of decision-making constituted? This constitution fact is related to environments where the decision-making process is placed. What is the influence of the socio-technical context in democratic decision-making? That's really the final and really important question with regard to the democratic decision-making in the tool we aimed at. And therefore, to do so, we have psychological as well as sociological methods on board to better understand these kind of decision-making processes in the first sense, and then be able to create models out of it. Thank you.
Thank you, Professor. Thank you for your explanation. I would like to take it to the level of models and to understand those things. Then we have working on the aspects of modeling, open models. So how can we describe those kind of things so that we enable an interaction by the human, as Professor has mentioned? How do humans interact in order to come up with to provide input, to collect opinions, to weight these collections, and also take a decision? And when we think about the artificial intelligence, how can artificial intelligence support us during this process? And there's, of course, support during the design, how we search things, how we learn from the past, how we support the decision-making process, but also from the human-machine interaction. On the right-hand side, you see our approach within FAIRWork that we think about models. And these models are a formal representation of the knowledge of the human, but also machine interpretable at the end of the day. And there's different flavors of models, of course. We can have processes, we can have rule models, semantic models, fuzzy rules. So anything that actually is formulated in a way that a machine process is possible. This has, of course, a relation to digitalization, since we will also have the opportunity to connect them to the assets within the company, within the production line, and actually feed these models with data in order to understand how such a decision can be taken. But I would like to spend a few more minutes now on the specific results that happened within the last 6 months, namely the scenarios that we have captured from our end users. They have been introduced already, so I will explain to you in the first step how we structure this process to understand the end users and their issues and problems with respect to decision making, and then actually give you some insights on what has been accomplished. So from a methodological point of view, we followed actually a process of 5 steps. The first layer, if you want to look at it from a horizontal perspective, relates to understanding the case from a multi-stakeholder perspective. So the idea is here to apply a design thinking approach, more specifically storyboarding, to actually capture the knowledge of the experts that are involved within the production process. Then actually transform those in a form of a decomposition into process landscapes, or precisely digital process landscapes, so that we can also operate on those, and decompose that further into business process diagrams, business process models that we can use as input for then the technical alignment that you see in step number 5 with respect to service discovery, alignment, and making the whole system happen. So tooling is provided here. Tools are provided in an open manner, so you can actually get those tools and work by yourself. For the first layer, we use the scene to model tool that has the objective to digitalize the storyboards that are the outcome of these workshops. For the blue part, for the second layer from a vertical perspective, we use the Adonis tool in order to understand how these digital process landscapes look like and to have a powerful analytical capability. And on the lowest level, we focus here on technical alignment, service architectures, and this is done using the Archimate standard within the architecture tool. So this has formalized knowledge that we can use then for further processing within the FAIRWork context. But now let's dive deep into the flex case, and I invite Roland to give us insights on what we have learned from this scenario.
Okay, thank you, Wilfried. So on the first picture, we see a schematic of a typical process like it is executed in Flex with all the necessary inputs for a project with the interaction between different departments and different operations. And if we jump in one of these operations, there we selected out 3 use cases, let's say. One use case is to get a decision model for the right automation concept system. Then we have the human allocations, relocations, let's say, and also we have the third use case, what is happen if we have a breakdown on a machine. So this is split up in 3 levels, what Wilfried mentioned before and explained before, with the scenario design, with the business process, and then with the topic of this project, with the technical requirements on AI, let's say. And we picked out one of these use cases. This is the relocation of operators. I think you can see me. Yeah.
Yes, perfect.
Thank you. In this case, we called it worker allocations. Is the case that one operator has an accident or an incident, and we have to react very fast to keep the production on like living, and therefore we want to have a smart tool where we can get a decision how we should follow the process based on skills of operators, based on environmental, based on no-go from operators, for example, if they want not or if they cannot work in a clean room, and also related to other production areas to find people they can replace the, how can I say, the missing person on the line without a big impact for the business.
Perfect. Thank you, Roland. So I think you get the picture we have here, a storyboard, a scene, and that is then translated into the process definition that Roland explained. So we want to find a smart way to find these replacements based on competence, but also on the context that this operator is within. Let's move on to CRF. Davide.
Yeah, hello.
Perfect.
Hello, everybody.
So the floor is yours. Give us some insights on what we accomplish here for your use.
Okay. Yes, it's Davide from CRF. Okay. Regarding the CRF scenarios, so by now CRF is working with other partners in order to clarify and formalize the overall case study. So in this phase, the contribution is mainly to provide all the information needed to define the perimeter of the pilot case, which is the production process of the molding line. That is very complex, and there are many variables and constraints, like for example. About 180 possible geometries, so part numbers or variants, each one including dedicating raw materials in entry, molds, and different containers in order to transport them. The production logic, it's a just-in-time type, often with a mandatory deadline for the following day. It is necessary so to face the unexpected, basically, so reacting quickly in order to take the optimal decision in the different situation. So here in the slide, you can see the first draft of the modeling of the production and decision making process. We got this result through several workshops sessions among the different partners. In particular, the most significant one took place in the beginning of November, so during the on-site workshop on the production line in Mirafiori, so in Turin, with the involvement of the different production experts and plant personnel. This was followed by a design thinking workshop session, so at CRF facilities with management experts. So from here, we have come to our first draft in which we have defined three possible scenarios. So the workload balance, the delay of in the providing of materials, and quality issues. Three possible scenario with the different logical flows, related KPIs and so on.
Great, thank you, Davide. Thank you for that. I think what we can recognize here is that this is a rather complex system that we have a look at, and this design thinking part plus the processes actually help us to understand where we can support and what kind of decisions can be supported by the FAIRWork outcomes. Just over that one, thank you very much. And I would like to hand over to Lucas to give us some insights on how this assessment of human factors are. We heard about operators. How are they impacted by the decisions that we suggest?
Yeah, thank you very much. Let's have a focus on the human operator and also about the environment, the workplace. We want to measure human factors during the execution of the task by means of digital sensors. As you can see top right, by mounting variables such as eye tracking glasses and by use of a digital twin of the workplace displayed at the left, we are able not only to measure biomechanical strain, but also cognitive emotional stress. Bottom left, you see the logged analytics of required concentration over the time, and bottom right of task switches. In the next slide, in the project FAIRWork, we will use not only research on the use of eye tracking glasses, but also biosensor shirts. Here we can see a dashboard with the real-time logging of the vital parameters, as well as metadata such as current stress level and other human factor-specific performance scores over time.
Great, thank you, Luke. So we understand we have the human actor that is important, and this information is also fed into the context of our system. An interesting question. We heard a lot about ideas, about challenges, about scenarios, but now we have to think about how can we make that happen. Herwig, can you tell us how do we make that happen? How does that work?
Thank you, Wilfried. Here you see the first initial architecture, and I will explain you the key building blocks for FAIRWorks to make decisions. On the bottom, you see the infrastructure setting that you're getting the data from the real-world use cases, which are in a production environment. What type of data we get here? First of all, we can have data from the planning tool, can have data from the manufacturing execution system, we can have data from the production process itself. This data is streamed to the knowledge base, or we have data from the human and biosensors environment, etc. This data is sent to the knowledge base. The knowledge base has two key components, a data lake to store the unstructured data, and on the other side you store the knowledge in form from structured data. This knowledge base can be enriched on one side by the configuration framework, which helps you to manage the overall system. And on the other side, on the right side, you can enrich it with a lot of different IE services. Here we use methods from data-driven AI, symbolic AI, or we use even hybrid approaches by agents, etc. This is put together and the data is enriched in this way. When you have a system or build a system for complex decision, you need also an orchestrator who carry out and execute the complex decision process. Here we have an orchestrator in the middle with one type of orchestration where you have fixed workflows, or in our case, for complex, flexible, adaptive decision process, you have also agent orchestrator. And we built in FAIRWork a system for humans. Therefore, we need also very flexible and attractive user interface where we have mobile devices, etc. And there you can view the dashboards and the right information at the right time.
Great, thank you, Harry. Let's dive a bit deep into one of these parts, and I would invite Richard to give us an idea of what does the knowledge base mean? Why do we need a knowledge base for all this work?
So as we know, data is very important for making decisions. So in our architecture, DIDSS knowledge base is a data repository where all relevant data from the production process is collected and stored. So this knowledge base is implemented based on EDM 2PLM, which is based on ISO 10343 step standard. So this EDM 2PLM will enable us to store digital models of physical assets like machines or humans or a process where we can store all the relevant information by modeling their parameters in that 2PLM. So this acts as a digital shadow or a digital twin of that physical asset. So based on these digital twins, the other components in our architecture can able to access the data and make decisions.
Perfect. Thank you very much. So we get the information, we have that one available, we have it persisted, and we can then run intelligent functionality on top of that. And what kind of intelligent functionality? So one type that we have in the architecture as well are multi-agents. Gustavo, can you give us some idea what we mean?
Thank you, Wilfried. So multi-agent systems that we developed for FAIRWork can take base on matrix structures as the European project Goodman. So it combines production with quality control on a local level, and it tries to optimize production parameters. In other words, machines taking decisions of which parameters to optimize. On the global level, collecting data from the products, trying to introduce optimizations in more than one level in order to eliminate the effects during the production process. The right side, there is a cyber-physical production system developed in academic environments, where a multi-agent system controls the production itself. When a product is requested to be manufactured, another agents, for instance, negotiate with a research agent regarding where and how this product can be manufactured, how the robots can pick and place parts. If you have multiple and different products to be produced at the same time, the agents can negotiate between themselves in order to rearrange production in a case a machine fails.
Great, thank you, Gustavo. So we have intelligence on the agent level that consumes the data and actually operates them. And this gets us actually to our final slide. It's my turn now to, as responsible for dissemination communication, to invite you to join us in. So this was one-way directional. We gave you the information that we have accomplished so far. And I kindly invite you to also join within the FAIRWork community to actually work on those kind of issues together. You find the traditional communication medias like email and web page listed here, but please feel free to join us also on the modern social media channels in order to get the latest news from FAIRWork and we're happy to have you with us, and please join further webinars as well. Thank you very much for your attention. I think we have 5 more minutes, so in case there is any question from the audience, I would be very happy to moderate those questions, of course. But first of all, I would like to thank all the presenters. You saw the whole consortium presenting what has happened in the last 6 months, and I'm looking forward to the next 6 months when we go into detail and implementation issues. Thank you very much. So I give you some seconds to think about, and in case something comes to your mind, then please feel free to raise your hand and join us in the discussion. Thank you very much. I have the impression everybody's happy, so we made a good job. Thank you, ladies and gentlemen. We will get a new invitation for the next webinar scheduled for March as soon as the date is ready, and then you will get even more information on the work of the FAIRWork project. For some private discussions, we will have our end user advisory board later on. So I invite those people to switch over to the other Zoom meeting to run those kind of things. Thank you and have a good afternoon and weekend. Bye-bye.
Thank you very much.